Hey friend, welcome back to the Sage Audio channel. Today we'll be discussing saturation for mixing and mastering, so stick around for the full video, but first, if this is a topic that you find interesting, I'd highly recommend looking into the blog post that's associated with this video. You can find a link for that in the description box below. Also, if you're an artist, engineer, or producer, and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you and send you a free mastered sample of it. All you gotta do is set up this short account, upload the song, and we can do the rest. Saturation is a term that's often thrown around when mixing and mastering without much discussion as to what it truly means. Now, of course, we all know the sound of saturation and can identify it when we hear it, but many of us don't know what it means when a signal is being saturated. Saturation can be broken down most simply into two distinct forms of processing: compression and distortion. When you have this combination, you typically create a saturated sound, one that incorporates both harmonic generation and the fuller and more dynamically balanced sound associated with compression. But there's a little bit more to it than just that. Saturation can sound different based on the machine that's being used for saturation, given the electrical components of that machine. It can also depend on the signal that's being saturated and the extent to which that signal is being driven, or in other words, the amplitude of the signal's input. Furthermore, the typical applications for saturation can vary wildly depending on the area of audio production being performed, whether that's tracking, mixing, or mastering. With that said, let's explore saturation from a technical and practical perspective. We'll be covering how saturation is caused during tape, transistor, and tube saturation, as well as what that means for the sound of the signal. Lastly, we'll be discussing how saturation is popularly used during mixing and mastering, as well as briefly discussing how it can be implemented during the tracking process. So, what is saturation? Well, saturation is the process of overloading the electrical components of a piece of hardware, which causes the incoming signal to no longer be represented in a linear fashion. Overloading the electrical components of a piece of hardware is accomplished by increasing the input to a significant extent. But what does linear mean when it comes to saturation? Well, maybe the best way to think about this is by comparing a linear input to output relationship with that of a compressor. When you're compressing, you typically see this graphic here. With it, you can get a visual sense of how the input is eventually output in a linear or one-to-one fashion unless you compress the signal. Now, typically when compressing, your ratio represents how the input will be compressed before becoming the output. Now, notice that when a ratio of higher than 1-to-1 is set, for example, let's use a compression setting of 2-to-1, the relationship between the input and output is no longer linear, and the signal begins to become attenuated. This same process occurs during saturation. When a piece of hardware's electrical components can no longer handle the electrical input that they're receiving, they can no longer represent the signal in a linear fashion. In other words, the signal becomes compressed. Now, as you can imagine, the more signal you feed into an already overloaded piece of hardware, the more the signal's output will become compressed. So, how does compression contribute to the sound of saturation? Well, just like with any other form of compression, compression caused by saturation will reduce the dynamic range of a signal. Now, this means that the signal's transients and loudest parts will be reduced in amplitude, making the quieter aspects of the signal closer in amplitude to the formerly louder aspects of that signal. Now, after compression, if you increase the amplitude of your entire signal, you have in turn increased the amplitude of the quietest aspects of that recording to the greatest extent. Now, this will make the sound of the recording more detailed and complex, as the often masked aspects of an instrument, a mix, or master will now become perceivable. So, how does soft knee compression relate to saturation? Well, the compression employed by a saturated electrical component is soft knee in nature, meaning that the signal will gradually be compressed as opposed to instantly, like with a hard knee setting. Now, this often results in compression that is less perceivable. Next, let's look at what tape, tube, and transistor or transformer saturation looks like. Tape saturation occurs when the magnetic particles embedded in the tape can no longer be rearranged or have their poles reoriented. Now, this happens when a loud enough signal is recorded that requires the entirety or majority of these magnetic particles. Now, if there are no more particles that can be reoriented, compression and harmonic generation will begin to occur. This will often result in both even and odd harmonic generation. Now, if you're using a plugin to emulate tape saturation, it's also possible that the plugin will subtly attenuate the high frequency range to create a perceived warmth. Now, it should be noted that although this warm sound is often associated with tape saturation, when a tape machine is properly calibrated, the frequency response will be balanced and high frequencies will be reproduced accurately. Tube saturation is a highly popular form of saturation and is used to evoke a classic sound in recordings. Tube saturation occurs when the electrons can no longer flow from the tube's cathode to its anode due to a positive charge that's been created between the two. Now, this positive charge initiates once the incoming electrical signal is strong enough, in turn overwhelming the tube, so to speak, and no longer allowing for a linear input-to-output ratio. Tube saturation creates a strong second-order harmonic, as well as both even and odd harmonics, depending on how significantly the tube is being saturated. Tubes often sound warm as well, but this is more likely due to the second-order harmonic, which is closer to the fundamental frequency and lower in the frequency spectrum. Transistor saturation is the most common form of hardware saturation, as transistors and transformers are more commonly used in electronics than tubes. Transistor saturation occurs when the input current has increased enough to cause a voltage drop, which in turn prohibits any additional electrical signal. Now, transistor distortion isn't often associated with a particular frequency response, like with tape or tube saturation, but it does result in a fuller, more complex sound. Transistor saturation contains both even and odd harmonics and depends on the transistor type. Now that we understand saturation from a technical perspective, let's look at things from a more practical side. Now, let's look at how saturation is used during tracking, mixing, and mastering. Saturation is used during tracking by driving excessive signal into the outboard gear used to amplify, compress, equalize, or otherwise process the incoming signal prior to its being recorded. Now, saturation during tracking is used predominantly in rock recording, but it can also be utilized in any recording in which distortion is desired. Saturation often occurs in amplification systems used for bass and electric guitars, but the hardware used for recording can also be driven to the point of saturation. For example, a channel strip that includes maybe a microphone preamp, equalizer, compressor can be saturated at each stage of processing, all prior to the signal actually being recorded to tape or converted to a digital recording. Saturation is used during mixing, both for a creative effect and to thicken certain elements of a recorded signal. By using saturation during the mixing stage of audio production, an engineer can create an upfront, complex, and sonically present sounding recording, as well as a creative or unique one. Mixing, being both a technical and creative endeavor, gives engineers the opportunity to attempt to make something sound great, both in a technical sense and a creative sense. For example, distortion can be used to make a vocal sound full-bodied, warm, and present, but distortion can also be used to make this same vocal unintelligible or a garbled and indiscernible mess. That being said, how saturation is used during mixing is entirely up to the engineer and depends on the context of the material. In short, an engineer can use saturation to establish a competitive sounding mix and or to create something entirely unique and unexpected. Most modern mixes, being created in a digital system, utilize digital analog emulation plugins to recreate the effect of this saturation. Now, more often than not, saturation is used during mastering as a way to augment low-level aspects of the signal and to fill in the gaps of a mix. By fill in the gaps, I mean that the harmonics generated and the compression used when saturating cause the dynamic range to become less significant, as well as increase the amount of information or signal between the quietest and loudest points of that dynamic range. Now, by doing so, you create a master that is louder overall, one that will translate better to consumer-grade stereo systems. Furthermore, saturation can be used during mastering as a means to evoke a certain tonality. For example, tape saturation might be used to allude to a particular era in music. Lastly, saturation helps to glue a signal together. By processing the entirety of a mix with saturation, the entirety of that mix is being run through a single effect, almost coating that signal in the effect. By doing this, you create a cohesive and uniform sound amongst all of the various instruments and vocals in that mix. So these are our thoughts on saturation, what it is technically speaking, and what it means for mixing and mastering. But what do you think? Leave your thoughts in the comment section below. Also, again, definitely check out the blog post where you can find a lot more information on this topic and others like it. There's a link in the description box below. Also, if you're an artist or an engineer, send us one of your mixes at sageaudio.com. We'll master it for you and send you a free mastered sample. All you have to do is set up this short account, upload the song, and we'll do the rest. But thank you so much for watching. We hope you enjoyed it. If you did, please like and share this video with your friends. This way we know if you like this video and you want to see more like it. Also, you can subscribe to the channel. We release new videos every week, and subscribing is the best way to stay up to date. There's a comment section where you can leave your thoughts on this video or a suggestion for a future video. And again, if you're an artist or an engineer and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you and send you a free mastered sample. Thank you so much for watching. We'll see you in the next video.